In this course, I will make an introduction of education NMR and MRI instrument. First, let's look at the classification of NMR instruments. The first picture should be the one we are most familiar with. Everyone has probably heard of MRI in hospitals. MRI is a relatively safe test without radiation. The image of MRI is listed here. We can get tissue information without damage through MRI. MRI is mainly used for the auxiliary diagnosis in medicine. There are low field, middle field, high field, permanent magnets, and electromagnets. MRIs in large hospitals have been upgraded to 1.5 Tesla or 3 Tesla nowadays. And there are also some small hospitals still using zero point 0.3 Tesla, a half Tesla MRI, such as small rural hospitals or the hospitals for pets. For such hospitals, low field MRIs are more convenient to use and there are less cost to maintain. The second type of NMR is the NMR spectroscopy. It can be used for chemical structural analysis. In chemistry, the pharmaceutical, food, and many other fields have applications. The application of the spectrum is based primarily on the theory of chemical shift. In a constant magnetic field, the resonance frequencies of the same kind of nucleus vary slightly due to their chemical environment. The difference is described in chemical shifts in parts per million or ppm. If you look at this picture, this is a molecular formula. This hydrogen nucleus are right here. On different chemical elements, if this hydrogen nuclei is in the same magnetic field, the resonance frequencies should be the same. However, each hydrogen exists in different chemical environment, and the differences between them are very small. And the NMR spectroscopy has enough resolution to pick up the differences in the frequencies of these hydrogen nuclei. Let's say this is a 100 megahertz NMR device, and the differences between the two hydrogen nuclei is 1 ppm. 1 ppm corresponds to 100 hertz. If this is a 800 megahertz device, then 1 ppm corresponds to 800 hertz. So the general NMR spectroscopy is also called high resolution NMR. It can distinguish the frequencies difference of the same nucleus in the same molecular chain with very high resolution. The third type of NMR is low field benchtop NMR. This type of NMR is widely used in the science research and industry. It can be used in the agriculture, the food, the materials, the fiber, and petrochemical, energy, and rock, and more applications. This type of NMR can also be configured for imaging and relaxation analysis, also known as time domain NMR. It does the analysis based on the time dimension. It is mainly low field, the permanent magnetic resonance. The field intensity is usually less than 1 Tesla. Well, this is a relaxation map, and this is T2. This is a timeline. This is a signal strength, and you can also image it like this, an image of lemon. Well, previously I introduced the classification of NMR. Today, I will focus on this benchtop NMR instrument. This is the education NMR. We call that EDU-MR series, the analyzer of NMR or MRI. I used a previous version of this when I was in the school. It's basically the same structure. It's been around for a long time. Let's start by introducing the corresponding parts of the instrument from the left to the right. Yeah. The first corresponding RF unit and the temperature control. Temperature control is used to control the temperature of magnets because permanent magnets are sensitive to the temperature. And this is also an RF pulse cabinet. Well, the second part is the gradient unit, which is used in the image making. It combines a gradient coil in the magnet to achieve the image. And the third one is the spectrometer, which is the brain of the MRI. And it can control the whole MRI system. And the fourth is the magnet cabinet. The magnet cabinet includes coil, probe, and gradient. Open the lid and you can see the structure inside. This is the plate, and this is the yoke. This is device probe, and there are two gradient coils on the coil plate. And it is through this waveguide that the sample is placed for an NMR test, as shown here. Here. As you can see, the sample is placed here into the probe. Okay, this is a schematic diagram of our system, and this is the control system. This is the control system, and it is it is installed with the NMR analysis software and imaging software. This part is the spectrometer system. The spectrometer system controls the input and output of the entire system. This part is the radio frequency system. Including the radio frequency amplifier and preamplifier. The gradient unit includes the gradient amplifier and a gradient coil. Finally, it's the magnet and the coil. Now, let's take a look at the workflow of the entire system. Let's say the magnet here is a half Tesla, and the Larmor frequency of the hydrogen nucleus in the sample corresponds to the half Tesla is 21 megahertz. Through the control system, the frequency of 21 megahertz pulse is set in the software. When this frequency is emitted, the signal is very weak initially. It needs to be amplified by an RF amplifier to reach the RF coil. The NMR occurs when the frequency or RF emission is equal to that of the sample. The NMR signals are detected through the coil. The NMR signal is also weak and needs to be amplified and the analog to digital when it reaches the amplifier before being stored in the control system. This is the whole NMR system detection process. If we need MRI, we also need to set the magnitude of the gradient in the control system corresponding to the gradient coil. A gradient usually has three directions of x and y and z directions for the spatial orientation. After setting up the three gradient magnetic fields, the magnetic resonance, the signal in the coil can be specially coded, and the specially coded signal is also amplified and transformed, and finally stored in a computer. Through the reconstruction of software in the computer, you can get 2D or 3D images. The workflow of the whole system is shown in this figure. We will show you the operation of the software later. Thank you.